So the number of cores in the CPU essentially um, um, correspond with the speed that you can expect from that CPU, the processing power you can expect from that CPU. It just basically means this computer can they can fare better with multi-threading and performing multiple tasks at the same time than the ones that have fewer number of cores. And there's a lot to learn about processing on the CPU level, and there's something they call DMA, direct memory access, that tries to relieve the CPU of some workload, right? But we're not going to be going so much into that at this particular time, but all of this information will be contained in and those materials. Like we said, this is a high level explanation of the concepts of the technologies that we'll be explaining and working on as we go on. And then whenever we see any concepts that I have not mentioned in this video, I would have to like take time to explain. But now I shouldn't be going back to explain what a motherboard is. I can now, in coming videos, I should be explaining more details about motherboard, not what the motherboard is in itself. And the same goes for all the other things that we've talked about before, like before this motherboard. Now this is what a motherboard looks like. Typically you see this one in the system unit of a desktop computer, and typically you see this one in a laptop when you open up a laptop. But basically you can see different, this is, if you look closely you would see that this is these are USB ports. This is a LAN port for you to connect your internet cable. These are USB ports. This is where you can connect your mouse. You can see different places you connect those hard drives, those I'm sorry, I mean to say RAM. From here you can see them, right? You can go here, you can connect them here. And then they have this is where the CPU goes. The CPU you see, this is also where you mount them. That's basically to explain a bit, to further explain how different components can connect to a motherboard. The same goes for this one I'm pointing at right now is for laptop computers, and as you can see that the battery connects at this particular point. You can see that your RAM can connect at this point, this one, right, can connect at this particular point. Even your processor can be connected, and these are slots for USB. When you connect your phone from outside, everything essentially connects to the motherboard, and this is where your CPU goes, if you see them, right? And then if you look closely, you will see even the capacitors that we talked about that are constituents of a computer being an electronic device. I don't know, you can see them, right? The other ones are too small for you to notice, but yes, this just explains it, that the computer is an electronic device, and this is what it means. It uses electronic components, and the motherboard is the board where these electronic components mount, and then the other one from outside, the peripheral devices have been connected to. So I hope you understand pictorially. We talked about power supply units. Well, this is the one for a laptop computer. We typically call it an adapter, and this is the one for a desktop computer. And yeah, so now we've finished talking about hardware. Everything we're talking about earlier in terms of component of computers is we've been talking about hardware. Now the next thing to talk about now is software. And software are basically the components of the computer that you cannot really see or you cannot touch physically, but they constitute instructions or code that enable the computer to perform certain tasks based on the instruction that the user is inputting, or instruction from the hardware device, or any of those particular things. They're also what makes the hardware to also work. So a software, there are different kinds of softwares anyways. There are softwares that are application level, designed to perform specific tasks. There are some softwares that enable hardwares to work. For example, driver softwares. There are a lot of softwares, but softwares are not physical. They are not the ones that you can touch physically like the hardware ones that we talk about. So in terms of system software, the ones that power at the hardware. For example, some of them are like operating systems, and the operating system is just like we have a motherboard as the mother of the mother hardware where other hardware components are connected. Operating system is also like a mother software where other softwares are installed on, where other softwares connect to in order to work. So there are different kinds of operating system, and the most popular one that we know about is the Windows operating system, which is what I'm using right now. But then there's Linux operating system, which you are going to be learning very well and extensively in the coming classes, because it's what you are going to be using mostly for this cybersecurity journey that we are starting. And then there is Mac, the operating system that that runs on Apple devices. It's called the Mac OS as well. So application softwares are those softwares that you install by yourself for some specific purposes. Maybe like you want a software that will make you to type. These are word processors that will make you to create documents. These are word processors. If you want the ones that will make you go to the internet, then these are web browsers, and then there are games. There are different kinds of application softwares anyways. So some of them are for designing pictures. I know Atto, there's one of us here that is a graphic designer, and you install Photoshop or CorelDRAW. That's an application software. And then some of us like to play Call of Duty. That's an application software. Microsoft Word is an application software. PowerPoint is an application software. Those ones that you can install by yourself for specific tasks are called application softwares, and they're also very important. In the end of this video, we'll be explaining why each of those softwares are important, all right, and how they all relate to cybersecurity. Then there's also antivirus programs and disk cleanup. These ones, softwares, right, for checking the health of your PC. They're also the ones that check the like system management, file management, your file explorer. Those other ones, that utility softwares they are used for general maintenance and well-being of the computer, like that. So they call them utility softwares generally. Okay, so we go to firmwares, and firmwares is the third component of computers. The combination of hardware and software, right? There's typically a hardware that's very important in the computer, but that particular hardware is preloaded with its own software that's working at a very elementary level, at a very basic lower level in the computer, and to allow certain functions to work. You understand? Some of them example is the BIOS and UEFI firmwares, right? BIOS being basic input output system, and UEFI unified extensible firmware interface. I think I hope I get that right. But yes, these are also firmwares, so they are responsible for the operations between that's the input and output operations that you carry out, right? And then by the time you power on your PC, from that boot process to full launching, and these are the guys that are responsible for these kind of things to work. There are also systems that are maybe like your modem, your routers, like that. You connect them to your PC, and then they perform the specific function that they are designed for doing. They are something they call embedded systems, right? So those particular systems have their own software that works on top of the hardware for a particular purpose. So there are firmwares also that work for graphic card. We've talked about graphic card. The graphic card is also another processor that is used if you want to relieve the workload from your central processing unit, right? And when it comes to graphic processing, you want this extra processor to do that. That's where the work of a graphic processing unit, a graphic card, comes into play. A graphic card can also be called a GPU, graphic processing unit, right? I'm going to show you what that looks like another time though. So so by explaining all of these things, I think we've done we've covered most for communication in a computer system, right? So a computer relies on a series of coordinated steps and pathways to transfer processes and data. The interaction between computers involves buses, control units, memory hierarchies, and peripherals. So I'm going to explain this in, I think time is up. This I'm using to record these sessions can give